Okay, I'm back. Okay, so everything's going quite well. We're at about 70 dwarves. I find, to me, this is the most fun part. When you have, it's the climb from 70 dwarves to about 150. Everything seems to go well. Okay, we gotta make a mayor room? Thought I had one. Couldn't I just... How many bedrooms do I have? 40, 80, 40, 80, 120.
And this time in the workshop is an AWA AD FF90 cassette deck. It's a lovely bit of kit. These were released in 1982. Very stylish they were at the time. Lots of buttons. I wonder if they work. This one has a pure amorphous alloy head, which I think was very special back in 1982. But what do I know? I was only 5. And it's also got Dolby HX Pro, which means it comes with a load of buttons for selecting different modes. I'm not sure these feel too clever though. Oh dear. Computer brain, the microcontroller in it for added trouble. And not too much going on around the back, which is a good thing. It's a tape deck. It's got stereo mic input and you got line in, record and line out and playback. All you need. Oh, what's this? MPX filter. Well, this is definitely a Japanese market model. 100 volt AC. Good job I got a Variac. I'll wind this down to 100 volts. There we go. Just got to deal with this funny plug now. So luckily crop clips work out here. Just cover them up a bit and keep them out of the way. That's a rather nice vacuum fluorescent display there, and it's not dim at all. That's very good news. Let's get a look inside. We can just about see the tape head there if you move the door in and out. Hopefully it's in good working order. I'll hate to have to replace that. We'll try taping there. Oh. Well, for some reason the door won't shut with the tape in. What is wrong? I don't see anything wrong. Just looking at the pinch rollers and the capstans, they're not engaged with each other. Now that would be a sign that the mechanism's sort of stuck in play position. But yeah, not sure. But it looks like mechanical issues. At least that's the start of it. You know how these tape players go. Oh, I don't know whether to be impressed or disgusted, to be honest. Wow. Like someone ate a bowl of wires and then puked them up. And there's a lot of silicon in this. I'm not surprised really. Computers back in 1982 had a lot of chips. Even got their own AWA branded ones. And more AWA branded ones down here. And another one here, which is an NEC chip. This is bound to be another microcontroller. Then we've got a Dolby branded chip there. And another two here. This was clearly a high-end machine at the time. Wow. The tape mechanism looks fairly conventional for the time. Twin motor design. This one's a servo one, I think. Keeps track of the speed. Let's turn it back on. And I'll straight away notice here just no action. I suspect that these motors should be running. These aren't. Totally stationary. Let's measure what's going on with the motor. Oh, 1.1 volts. Let's have a look at this mechanism, see if it takes a tape or why it won't. Oh, it does now. So will it play? No. There's nothing happening. Nothing at all. I'm a little bit suspicious of this motor because even with 1 volt going on it, it should probably turn a little bit, or at least I should feel something. But it does feel very, almost seized up to me. I suspect there's mechanical trouble. Just fishing around these wires, this brown wire can be traced down to this plug here. So I'm just going to pull that out so I don't blow the circuit up. I'm just going to put 12 volts on, straight onto the motor. Let's give it 12 volts and a good dose of current, maybe an amp or so. Let's try that. Oh dear, no movement at all. That motor's got to come out. I think this is going to be a right pain to get out, and I've just remembered, I hate tape decks. First place to start is normally take the cover off, which can be a challenge. Oh, not in this case. I'm just going to start pulling screws out of this. Will it come off? Oh, yes. I've certainly loosened everything. Will this come out? Oh, maybe. It's out. Yes. It's probably fair to say the belts are a bit stretched, I mean, as they've just fell off during the process of taking the tape deck out. A few more plugs to undo. And this big long one. Luckily they're all different sizes, so I can't get it too wrong. Of course there's quite a lot of wiring to these heads and the erase head there, yeah. I had to trace these wires too. One lurking down there. And the others are just here. It's certainly well made, look at that. There's not a lot of plastic on this. The audio files will go nuts for this bit, but the problem's around here. And there's just 3 screws to get this back frame off. Oh, okay, 4 screws. I hadn't looked. And we're off. Oh, and this is C solid. Wow. Okay, we found the problem. Just slacken these rubber mounts off. Hopefully it just twists. Or if the rubber's not knackered. We'll just do them all the way. Just going to unsolder these wires. Well, it's 41 years old almost to the day, look at that. And this is pretty seized. Oh, it's loosened off. Oh, and then seized up again. Oh, no, it's loose. It's tight. Oh god, something drastically gone wrong here. I'm going to have to pull this motor apart to see if I can fix it, and this pulley might have to. It's best to check the heights of that before I go any further. So from the bottom of the pulley to there is just shy of 4mm. I don't know if it matters. I'm going to put a little mark on there to show some deep alignment. A little bit of levering here. Hope it pops off. Oh, we're lucky. We're lucky. Okay. I'm not sure which is the windings on here, so I'm just going to unsolder a few places. I'm not sure that's helped. I'm going to pull this pulley off. If it'll come off. Oh, it will come off. See what that does for us. It's still not coming off. I'm not quite sure why. I've undone the 2 connections to the actual motor itself. This little servo board is stuck. It feels to be pivoting around here. And if I didn't know better, I think this transistor's actually stuck. Is it? Yeah, look at that. I'll just keep unsoldering stuff. That's got it. Well, that transistor appears to be glued on. Yeah, I don't think it's melted on. Well, it might have melted on. Well, either way, it's stuck on there now. And this board doesn't look too clever either. Yeah, that inductor here has had a fair bit of heat stress. Look at that. Probably not too bad though. Hopefully it's not too damaged. So I bet that transistor's knackered. Just going to put some proof marks on here as well, just in case it matters. If I can get the pliers in this slot, see if I can straighten these little tangs out. Looks like I have. And it's away, look at that. Oh no. This isn't a good sign. The windings are all different colours. Yeah, this is seized up. I wonder what caused it to seize though. That's interesting. Whatever it's seized up has made it burnt out. Let's measure from one segment to the next. 3.8 ohms. Okay, round here. 2.9. Okay. About these two. Nearly 6 ohms there. Wonder about this transistor. Oh, amazingly, it's okay. I've got to be honest, this is quite a serious problem, and there's only one way to fix that. Unless I've got a time machine and can go back 40 years to buy a new one, I've got to rewind it. This is not the most complicated of motors to repair. The 3 windings are quite separate, and the windings of the wires are just joined on this disc. The real question is, are the windings all gummed up with some sort of resin or varnish, or will this unwind neatly? Because I've got to count the number of turns on here. And luckily I've got just the gadget to do that with. I've had to modify this and put a 4-jaw chuck on there, which was quite cheap on eBay. Made in China. Perfect what I need. Just having a look under the microscope at this, you can just see how the windings are formed on there. And they look a little bit loose, to be honest. I'm hopeful this can come apart easily. First things to do, this is the burnt winding as you can see, is undo these little solder connections there. Just going to get the tweezers in there. Try and get them just underneath the wire if I can. I wonder if this is wrapped around something. This is the old trick they do. go, we're off. I think it'll be an advantage if I can take this disc off completely and disconnect all the wires, because this will be in the way for the rewinding process, and as it's lifted off so nicely, I'm going to fetch it off. Yes. I think I need a solder sucker to get this solder out. There's one. So now it's ready for unwinding. Just going to clamp between these two jaws into where this wedge is. Just nip that up and try and get it to sort of sit centrally between them. See how that lines up. That's pretty good. The only problem I've got is the way this is wound, the number's going to count down backwards, so I'm going to have to be mindful and just keep my eye on that. So we'll reset it, and you're going to gently go for it. There's a little bit of stickiness in this. I don't want to break the wire. This could be a slow job, I think. What I found I need to do is melt the lacquer on this. Bit of butanone or methyl ethyl ketone, and just feed some onto there, just a few drops. That soaks into the windings and loosens it all up, because there's a lot of glue on here. Let's find a loose end again and continue winding. So, 578 turns. That turned out to take quite a long time, about an hour in total. Luckily I've edited it for you. But it turns out the solvents need quite a bit of time to soak in and soften it all up. And I'm not going to count the turns on the next ones. I think I'm just going to sort of hack them off. See how I get on. I think this is taking a bit too long, so I'm just going to start hacking it like I said I was going to. The bottom layers are stuck in the glue, so I need to put some more solvents on there. See if we can soften that up. We'll have this off in a few minutes. Should be able to get under it now. Well, now the coil's off, just having a look around. It doesn't look too damaged. I think we can work with this. I'll check the commutator for damage to make sure I've got continuity from there to there. Yes I have, but not to the shaft or here. Good. Also from the one to the next one. No problems there. Good. In fact, I'll rotate this. it back in the chuck. Nicely aligned. I need to check how thick this wire was. It's pretty thin, but I need to measure it. It also feels a little bit rough because it's had all sorts of gunk on there and it's been sticking together. So the reading's going to be a bit higher than it should be, I reckon. Let's see what it is. That's measuring 0.13 millimeters, and that's pretty close to this 40 gauge wire I've got here. Let's just measure how that works out. About 0.135 mil. I'd say that's pretty much the same. Just load it onto the machine, put that little bobbin on there. Okay, I'd like to put a bit of insulation around the core of this so it doesn't sort of chafe the wire. By the end of the wire, there it is. Pass it underneath there. I'm just going to wrap it around here, just as a bit of a way of anchoring it whilst I start the wind. Well, that's the lot. So if I can get this wire around this lug if I can. So check the resistance of the windings, check they're all balanced. That's good.
Shit.
Perfect. And over here. That's great. I'm also going to check we haven't got a short to the armature. And we haven't. Now I've got to solder on this little disc. It's actually a ring barista used to snuff out any high voltage spikes which would cause damage to the brushes. Pop it on there, just line the little pads up. There's a black mark on there, that's perfect. So I just need to make that stay on there whilst I solder it. Put this bit of blue tack, well it's not blue tack, it's white, whatever that is. I think it's Pritt Stick's version of it. Anyway, it does just a fine job there. Just check that this is lined up with the original solder points. Yeah, that's good. And so is that. Just check it's running concentrically. Yeah, it's pretty good. As I can tell, that's pretty good now.
awesome trade.
And it's going to be spinning around like that, so I'm going to put a little bit of lacquer on these windings just to firm them up a bit. I'm going to use this electrically insulating varnish. I think it's a polyurethane type thing. It doesn't say. Just going to brush some on.
This is mudstone. We need mudstone.
I think that'll do. I could really do this transistor coming off here. I'll see if it can be yanked off. Perfect. Now I've got the servo drive board to deal with whilst we're waiting for that varnish to dry. I'm going to try and put that transistor back in now I've got it off. There we are. Looks a lot neater now. Just going to solder these legs back in. I've already checked this transistor to be okay, so there's the base. We've got a good junction there and there. Yeah, perfect. I'll check around a few other bits. There's some diodes down there. There's one there. Yeah, that's fine. And another one here. Oh, that's not fine. Since I found some shorted silicon, I need to check some resistors, although they don't look burnt. Got 2K7 there, that's bob on. Then we've got a strange value here, this little one. What's that? 6K2?
Where's
That
the
looks
box
convincing
light?
reading anyway. Over here we've got 27 ohms. Yeah, perfect. What's this up here? Oh dear. 82K. Yeah, 4.8K. That's not what I expected, but it could be right in circuit. Then finally we've got this one. What is this? 5-band resistor. Grey, is that red or orange? Oh, and a black. 883. Yeah, 883 ohms. And it's measuring 51K. That's not good. With this sort of damage on there, I need to work out what's going on. So I've decided to have a little bit of a sketch of the circuit board and find out what's going on. I've come up with a little schematic. To do this, I've just drawn out where the components go and given them all names, just labelled them up, and I'll turn that into a proper schematic. And here we go. This motor control trip is made by Panasonic, I think, or Matsushita, but I can't find any information about it whatsoever. And this is the circuit and how it's wired up. So we already know that this transistor was getting hot because it was melted into the casing. And we've also seen this diode is short. And the other thing we found is this one, which is a fusible resistor, I think, as open circuit. This is overheated as well. So it looks like current has flown through the transistor, down to the base. From here it's gone straight to the shorted transistor. We also had the windings burnt out, so some it's gone. I don't know what went first, but yeah, hopefully this chip's okay, because I'm not sure how easily I can get them. Another mystery, well, we've got these two resistors in series. This one obviously is fusible, and we've got 27 ohms plus 883, I guess. That adds up to be 910 ohms, which would be a standard. I just really don't know why they've gone with this value. That is so strange. The thing with fusible resistors is they're normally rated for something like 1 watt, and at that sort of power the temperature rises in here and that blows the elements. So it's a thermal thing. The problem I've got though is 883 ohms. The sort of current to make 1 watt is about 33 milliamps. That's really tiny. I don't think I can get this at all, and I don't know if I can get a 30 milliamp fuse. So I'm afraid this is going to have to put a standard pair of resistors in. Well, not that and that, that and that. Let's desolder the offending parts then. Hopefully I've unsoldered the right bits. I think I have, that's all loose and wobbly. And whilst I'm desoldering things, I might as well take these caps out because I don't want any comments off the capacitor police, do I? So I'm going to measure this 4.7 microfarad cap. 4.95 microfarads. It's not far off, it's a bit high, which makes me think it might be a little bit leaky. Now let's see what's happening with the 0.22 microfarad cap. It's rather a small cap for an electrolytic, I have to be honest. 0.9 microfarads. Yeah, that's very suspicious. These are probably past their best. Now to stuff in the new components. We'll start with this resistor here. I'm actually installing an 820 ohm, not 883, because I can't get one. But to compensate, 27 ohm resistor to 100 ohms. Now these particular two I've already measured, and they come up with 911 ohms, which is very close. I couldn't find any information about the diode that shorted, but it looked like a small signal diode, and it only had the letter H on it, which I don't think means anything. But I'm going with a 1N4148 because I think it's probably beefy enough for what this is doing. I've managed to find a 0.22 mic cap in the box. Very happy about that. So straight swap, and it fits nicely. And same with the 4.7 mic cap, readily available. Snip those leads off now. Because I haven't got a fusible resistor in here, I've left this stood off the board so it doesn't burn it in the event of a big overload. This gives it some chance of being repaired again. This should be ready now as well. I'm really pleased how this has turned out. It looks nice and it feels good, nice and solid. The varnish has done its job. So I'm going to put it back in its housing, but first I'm just going to lubricate that bush. Just a little bit of oil in there. So I've got the motor end cap here, and there's the brushes inside. They're sort of spring brushes, and they need to be pulled apart so they don't get mashed up when I put the shaft in. I found you can just poke some tweezers in, and that should separate them nicely. So the painstaking part of just sliding that in there. That should be good. Well, that looks lined up nicely, and it turns freely. That's actually just going to squeeze these two little tangs back up, stop it falling apart. A bit difficult to get at, but just a little squeeze with the pliers. That should do it, really. Okay. I have just noticed this little arrow where the transistor used to be smelted on. There's an arrow pointing to the direction of rotation. I guess we should check that, because I don't know which polarity these are. So I'm just going to put a bit of power in there. Maybe just a few volts, don't burn it out. That'll do. We'll try negative on this one. Put the positive lead over here. Turn it on. Not sure which way it's going. Just see through a little gap there. I can feel, yes. Yeah, that's correct. Mark that little plus. Okay. According to my diagram, the motor positive terminal is in this corner here, or there. So, I'm just going to connect it like this. Luckily it fits as well. Just going to solder that on, just need something to balance this on. This will do. Let's connect the power supplies on, see how it runs. Well, I can hear it whirring. See if there's any speed adjustment. Oh no, None at all. Oh, this is a bad sign. Pick up the ground there. This is the motor output. That's 11.1 volts. That's pretty much flat out. This is the gate drive or base drive to that transistor, 11.2. Yeah, that's calling the transistor to be turned on. That's why. What else can I see?
Migrants.
We've got pin 3 is a reference voltage. Bang on 1 volt. I reckon that's okay. Pin 2 is the other side. That's the negative part. So we've got 10 millivolts there. And this is the reference 0.3 volts. Yes. I wonder what's wrong. It measures believably. Just looking back at the diagram I made with a lot of assumptions about this chip, I have noticed something just. I've got a resistor here and here in series, which I said was weird in the first place, with weird values. But of course this current is going to come from the positive supply through the base, straight through here, and just back through this circuit. So no wonder this transistor's on. Maybe I'm wrong about this resistor. Maybe it's not a resistor. It could be a capacitor. It's still strange colour bands on there. I don't know what they mean. That'd be 103, which could be 10 nanofarads. Don't know what the grey bands are though. Well, there's no harm in measuring it. 12 nanofarads, it's about right. And that component sat right there, and I stood that off the board, and it's right on the edge. I think I can just unsolder that and just test it without the capping. Probably run okay. Pull that out. There we go. Let's put the power back on. Well, straight away that's running slower. I can hear it. That's perfect. That's working. So that confirms it. It was not a fusible resistor that had blown. It was a capacitor. I'm allowed a mistake in every video. Those are the rules. So this isn't right at all. So it's actually a capacitor. And we'll call it C4, like the explosives. And it was 10 nanofarads. Well, that's completely desoldered this now because I've got to change that 27 ohm resistor back. Well, I'm getting a bit fed up of seeing this board, I have to admit. Let's put this one back in. Well, the legs are a bit bent in an awkward position now. Same with the original capacitor. Give it another test. That's perfect. I'm happy with that. So that can now go back in its original housing. And the lid, exactly the orientation it came off on. There we go. Perfect. Just need to put the pulley on. If I remember, it's about 3.7mm from there. So I've got a 3.5mm drill, should be close enough. Just going to sort of drift it down. That should be exactly how it was when it came off. But working. The motor was fastened to this plate. If I can find the holes. There's one. Now back to the tape mechanism. Before I put the motor on, I'm going to replace these belts because they seem to be falling off. Although they don't feel bad or sticky, which is a nice change. I assume the shorter one goes underneath. Let's try and wind it on. Lovely. I'm going to hook the longer belt over the motor pulley to keep some tension on it. So I think I'm going to have a bit of a struggle here. So just wrap it around there. Well, that's all looking very satisfying. Just retin these solder pads for a bit mullered really. It doesn't look in too bad condition down here, though it could probably do with a bit of a clean. The rollers don't look too bad, but I'm going to change them. And that's mainly because the new pinch rollers came with the belt, so they might as well be fitted. The left side's got quite a few springs in there. I'm a little bit dubious about this, but I'm going to undo this little nut, which came off by finger force. That's unusual. Not to let these fly off. But it looks the right size, so I'm going to pull this pin out. I'm a little bit worried about that. I hope nothing breaks. Well, that was too easy. Hopefully this will go on without springs flying off everywhere. A little washer back on. And then the little nut. That's better. The right hand side's held in with this little clip, but you need to open the cassette door to get in it. It's going to disengage that spring to make life a bit easier. Pull that hook out of the way and lift it out. Hopefully this one goes as easily. Oh, see, this is now how I'm used to them. Yes. This causes me a little bit better than those pliers. There we go. They're the same size? Yes, they are. Oh, it doesn't want to go in. God, that's tight. That's no good. Oh, what's wrong with that? Can't get it out. Let's check the thickness of this. The original one. 7mm. Okay. And this one? Oh, back 0.35. 0.4mm bigger than the other one. I just need to sand this down a bit, I think. Get in there. That's better. Poke this shaft through the hole. So just stick slightly through. Push our rubber wheel in. Just try and line it up centrally. There we go. Perfect. Just feed the spring back over there and we're ready. Just wiggle it around here, get it past that mechanism. Okay. Let's clean these heads with a bit of alcohol. Just rotating it. I can't actually see any muck coming off, so probably not that dirty in the first place. Just dusty, I think. And that one there. I think that's the erase head. Let's give these capstans a wipe, just in case there's any muck on them. It's awkward to get at, this is. Well, I think that's it. Ready to put back in. couple of screws back in. Let's plug the heads back in. Bit of a tight squeeze in here. And this one's even worse. Crikey. Might put a tape in, just on the off chance this works, and power it on. Still nothing. I only get that light blinking. What voltage are we getting on here? Oh, still 1.2 volts. More trouble. I hope this thing's worth a lot of money because it's becoming a pain in the bum. So there's more trouble in here somewhere. This has got to come apart more than it is now, so let's loosen this cover off. Actually, I want the whole back panel off, so all the screws are going to come out. Oh what? The back of that DIN socket, it's got little plastic pegs. It's got to push them. Well, this looks power supply related with the heatsink, big transistors and big capacitors. And straight away I'm seeing this. This doesn't look very clever. I don't know if these are dry joints on the bottom, but they could be. It's certainly got hot. I'm guessing that's where the 12 volts comes from. I couldn't find a manual for the AD-FF90, but I found this one and it looks very close to me. And I'm wondering if this is just the European version. So this was issued in 1983. Not entirely sure where the components are located because this board layout is not very legible. But that burnt resistor's around here somewhere. I'm trying to find it in the diagram. This is where the 12 volts is regulated and these components look to be connected roughly in this way. I reckon it's right. You can see the 330 ohm resistor there. It must be an early board. Those two Zener diodes are occupying one place. And if that's right, that's a 1 ohm resistor, half watt fusible. I did mention that you don't see these for sale that often, but I do have some. I'm thinking 1 ohm is very likely to be fairly normal. Although these are quarter watt, so no. Oh, half watts. Perfect. And yes, I'd agree that's 1 ohm. Brown, black, yeah, okay. Wonder what it measures. Well, that's basically open. Let's go check this transistor's actually okay. Okay, good. Yes, no shorts there. Oh, great. Just slide that in there. We'll get the holes to line up. There we go. Resolder these. There's a few dry looking joints around here. It's going to just give them all a little touch up. I think this old insulation tape is supposed to be insulating these from the chassis, and this isn't going to do it very good anymore. So I'll have to replace this. Just get the tape underneath it all. Sort of just try to encapsulate it a bit. Just want to clean some of this muck off here, the solder flux and residue, and just make sure it's actually all okay. I think it will be. It's always worth a check. We've got a rather untidy production bodge here. This little cluster, this one's actually touching that. That can't be good. Yeah, this is another one that could do with a bit of insulation. Let's try and sneak that under there. Right, I'm going to put this back on just for a bit of structural integrity, because that board's holding all the weight up and I don't like that. Let's see if we got the 12 volts now. Well, we got 12 volts. What's that racket? Well, I hope that's not the motor. It doesn't feel like it, to be honest. Yeah, the chassis is rattling. It's speed related. There's something wobbling around the bottom of this solenoid. That shuts it up quite a bit. Yeah, some mechanical issues. Yeah. Something not engaged right. Oh, hang on, it's supposed to go that way. And it makes no noise. It's all moved into place. The motor's going backwards. I can't believe I did that. It's not too difficult to put right, but I've got to take it all out again. Let's pop this lid off again, very gently. There we go. So all I've got to do is just turn this round. Like that. Look, I even put a plus on there and everything. Let's pop the lid back on. Let's try it with the motor going the right way. That's better. Nice and quiet. That is damn near silent, that is. I'm very impressed. At least the motor's done. Will it play a tape? Oh, that's not great. The take-up rollers aren't moving. Why aren't the take-up rollers moving? Oh, is that me tape? Oh, bloody hell. Hopefully it just comes out. Nah, not too bad. Right then, this motor that I heard running is supposed to be driving these take-up rollers, and it's not. The mechanism is all sort of at the front, so I've got to take this cassette tape holder out. It's all sort of dowelled and riveted, so not easy to remove. There's a couple of screws, so I'm sort of fancying those. Hope they get this apart. Oh, it still won't come. Oh, it's trapped. Ah, more screws back here. Well, there's a mechanism. The take-up reels are here. There's a little brake on there, and this would be the drive reel, I think. Just going to connect some power to the motor just to drive it so we can see what's going on. Just lift the brakes off. I can see the pulley spinning, but nothing else going on. Wonder if this idler's jammed. Just need to strip some of this stuff out of the way. Take this lever off. And this little spring retainer. Hopefully it doesn't all come flying off. Just need to get the heads off now, so I think I just need to tip that up there. Just a little wiggle. Yes. And we're free, sort of. Put some power back on that. Yeah, it's just spinning. Yeah, it should be working. See if I can just flick this off. Awful little circlips they are. There we go. Oh. Why is the spring on top of there? That can't be right. That felt pad, surely, should be operating on the back of this idler. I reckon it should go on like that. If I can get it on. There we go. Then the spring goes on there, not behind it. Then my favourite part, putting the washer and the clip back on. Oh, this is always going to be a challenge. Hopefully I can just press this on with my finger. It's a tricky job. Just lift the brakes off. Oh. Still no good. I don't know if this tyre's worn. It doesn't look too bad. It's not cracked or anything. Feels nice and soft. It's not got much springy tension on there though. In fact, has it got any? Turn that back on. Oh, I have to lift the brake off. I keep forgetting. Look at that. Slightest bit of tension added. It's working. Pretty sure there should be a spring on this pulling it up. Yeah, I need to do a bit of digging. Knowing what these things are like for springs shooting off, I'm going to disconnect this brake. There's a spring there, waiting to fly off across the workbench. It's also a good idea to remove the heads. And this will have to come off again as well. I'm getting good at this now. And the capstans will have to come off. Pull those little retainers off. There we go. Now I can unscrew the motor, get that out of the way. That just lifts up. So here's our idler flapping around and there's no tension. And what's that there? There's a spring flapping around. What's going on? I see a little retaining clip there and this spring's just not doing anything. Yep, that's better. That's got more going on. Now the fun's going to begin. That little peg on the end there has to engage in here on the motor. Oh heck. Just very gently tease it in, keep it in position. That could be good.
Okay, I don't actually have to fight this because I didn't. Oh
We'll try
boy.
it now. Oh, you're kidding me. No way. Let's check this tyre out, you never know.
They can't get me.
Cheeky. I caught that though.
There's no way for it to get me.
At first glance it doesn't look too bad. But, oh, look at that.
And in fact, it left
It's
anyway.
really strangely. That's almost a trapezoid. Well, that can come off. Well, I found this. It's a similar size, pretty close actually, and it'll fit. And importantly, the edges are straight. So I'll pop that on. Okay, see how that works. Put the washer back over it. My favourite part. Let's try that. Oh wow, still no good. It's like it's not pushing it hard enough. What's going on? There's not a lot of movement there. I'll take this plate off. So what can we see? That's the bottom of the arm. It's still got the spring on it. It don't have much room, does it? Well, that's no good at all. It's as if the motor's too big. Oh, look at this. It is. It's got this magnetic shielding around it, and there's several layers here. What, 4 layers, and round here there's only 2. just need to spin this round. Well, these wires are a bit of a problem. They might not like it. Well, that looks better. It's not banging into the motor body now. Maybe that's it. How about now? Oh, look at that. At last, things spinning in the right direction. I'm a happy boy now. Let's try the other direction. Swap these leads over. Excellent. Very happy with that. Put the capstans in. And fit the belt again. Hopefully for the last time. Let's push the little retainer clips back on. Next to brake assembly, you need to put the spring on there and hold it like that. Then steer these little pegs into the sockets. There we go. Before I put the head assembly, I'm just going to put a bit of new grease in there. There's a ball bearing that slides up and down to support the head. I've got some very sticky red grease, which is ideal for these sort of things. Just drop it in and it should sit still. Stuck in the grease, excellent. The trick here is to engage this T-slot on this plastic peg here. It's a little bit awkward. Next part is this spring, which should have a ball bearing under there. But you know, I never saw one come out. Now normally I think that was me, I lost it, but given the problems I found on this, I don't think it was me. Just got to get the spring hooked over here. And then it just pulls over this little tang here. Put a little dab of grease on there as well. If you're going to be messing with tape decks and stuff, it pays to have spare ball bearings of various sizes. These ones are 2mm. And in it goes. Hopefully it stays there. Just line this slot up with a plastic post. There we go. And that's fairly firm as well. You don't want your amorphous head flapping around. Then we've got the brake release arm. Let's put this cassette door mechanism back together. The side plate's a little bit awkward to fit, so I need to twist that round into engagement there. Got to clear the eject button. Yes. Should probably wipe my greasy fingerprints off here. Probably no good for the tape. But it's all back together. See if I'm lucky, because I haven't been very lucky so far. Oh, that's new. It didn't do that before. Oh dear, I think Belinda's balls have dropped. All that motor's running slow. I will change it for something I can measure. This tape's had a bit of a battering. Should be 3 kilohertz though. Yeah, that's quite a lot though, that is. Let's find the adjustment hole in the back. There's a pot in there if I remember. That'll do. Well, that doesn't sound too bad at all. Looks good on the scope as well, pretty even. This is looking okay. Not sure why that's flashing, not sure it should be. And what's this doing? Absolutely nothing. Let's check it fast forwards as well, shouldn't I? Oh, that's great. Rewind. Yeah. Play. Pause. Unpause. Yeah. Happy with that. Not sure what this does, but it's an 80s thing, so this will definitely be lit up. They like lights lighting up then, didn't they? This tape deck's got even more problems, but it's not a complete failure. I've made quite a lot of progress. I'll have to drag it on to another episode. Catch you next time. And still on the bench is a somewhat overcomplicated AWA AD FF90 cassette deck. In the last episode we fixed a burnt out motor, a missing 12 volt supply and a fair few mechanical gremlins, what with it being assembled not quite as the factory intended. Okay, sit rep. Things have moved on, but not in a good way. My vintage scope's lost a channel and the motor I rebuilt's gone wonky. Luckily there's no shortage of scopes on this bench. I've also loosened off the front panel so I can get better access to the main board, because I think it's going to get rather complicated. I was hoping not to have to mess with this motor again, but I'll show you what's up. It's best heard with this test tape. That motor's been calibrated to play this tape at 3 kHz output, and look at it, it's all over the place. Although not so bad now, I have to admit, but it does drift up and down. I don't fancy taking that tape mechanism out again, so I'm going to try and work on the motor in situ. I reckon it's a problem on the board, maybe. Doesn't probe it's 12 volts on the motor. 12.3 volts mean, a little bit ripply though. I'll play the tapes, put some load on it. No, it's not so great. And now it's running faster, look. I should probably sort the power supply riffle out before I start blaming the motor too much, but I don't think it should cause that problem. It should be sort of independent of the voltage, but I suppose I'm changing some caps. Just fetch the back off again. And the main power supply caps must be these here, and this one even looks a bit heat stressed, with these plastic covers sort of shrunk. In fact, they are rather hot. Blimey. It's not just that. Yeah, they definitely want changing, I reckon. Although this one nearest the back is quite new. Look at it, it's not the original. You can see the glue at the bottom's been pulled away. Must have been a problem before. Let's start with this one first. This one's got the glue on it. There we go. There's one more hiding down there. They've definitely underestimated the size of these caps on this board layout. They're a lot bigger than those circles. Just for kicks, I'm going to test this newer Rubicon cap. See if it's actually as good as I think it is. Yeah, the Rose Gallery, some of these do look rather worn out, I reckon. But this one doesn't. Looks very modern to me. In fact, I think that's a 2008 date code, maybe. Still fairly old, I guess. Let's test these one by one. Start with the newish Rubicon. Just under 2 millifarads. Okay, not bad. This is the old 2200. What's this? Wow, 2.2 millifarads. I don't know what to say. That's really good. This is supposed to be 1000 microfarads. Yeah, not too far off. $440? Not terrible for a 470 mic cap. Not the disaster I'm looking for, to be honest. Yeah, slightly worse. Finally, what's this one? 400. That one is low, but yeah, I was hoping it'd be like 50. But again, not the disaster I was thinking of. Let's clean some of these holes out. Rescue that little bit. Well, in with the new caps, I don't think it's going to make a huge difference. Let's just bend its legs a little bit, stop it falling out. And another brand new Rubicon in here. Well, it'll look neater and it'll keep the capacitor police off my back, but I'm not convinced this is going to fix it. Moment of truth. Let's see that nice steady DC. Looks the same to me. How about plain? Yeah, I think that's no different whatsoever. That's a load of caps wasted if you ask me. Let's knock the power off and get inside that motor. Comes off a bit easier now, I have to say. The motor's a bit loose now, so I'm going to jam these tweezers under here. Stop the motor coming adrift. And hopefully I can just remove the board just like this. There we go. I'm just going to solder wires onto here so I can run the board externally from the motor. And I have remembered that little positive on there I drew on is wrong. So I'll put the wires the other way around. I'll put these wires to this little hole here. I can put the cap back on. In fact, I'm going to disconnect this entirely. I'll run this off a bench power supply just to prove it works. Just tap the motor wires on here. All these red wires still need to be joined together. Let's not forget that. Let's connect this to the bench power supply. Give it 12 volts. That's still running quite quick, but it's starting to fall slightly. Instead of interest, I wonder what the voltage is on the motor. 6.6 volts. So you can see the input voltage hasn't got much to do with it. I've got a theory this chip might be a bit dodgy. I'm going to warm it up with the end of the iron. Oh, Yeah, that's it. Gone temperature dependent. Or a bit leaky. Try freezing it. Unfortunately, I think this AN6618 driver chips had it. It's no good for speed regulation. I also mentioned I can't find any of these to buy or any data for them really, so I'll have to put something more modern in. It's a complete new circuit, I reckon. And this thing looks perfect, and I've even got one. Brilliant. And it really has simplified the design. There's only 4 pins. If you scroll down, there's even an application note. How to wire it up. How easy is that? Lovely. I'm just going to test this circuit on the breadboard first, because I've got to make this fit in the back of the motor, which means I'm going to have to do a custom PCB, and I don't want to do that and find out it doesn't work. Here's a trusty old breadboard. Seen many designs, prototypes on it before. Start with the motor driver chip. Let's get the legs to bend in. Pin 1's a 12-volt supply. Let's pop that in there. Pin 2's got a 330 ohm resistor going to the 12-volt rail as well. Pin 3 is ground. Pin 4 goes to a little trim pot. And the other side of that goes to pin 2. And of course the motor output is also on pin 4. So that's the ground, that's the 12 volts, that's the motor negative, and motor positive I'll put in here. Although I haven't specifically wired in the positive, so here we go. Just unsolder the motor wires. There's the other. Put these crop clips on the cables there. Power it on. 6 milliamps, that's a good sign. Well, it's definitely going slower than it used to. But how slow? Start the tape. Yeah, that is running slow. Let's see if I can adjust it. Let's give it the thermal test, put the soldering iron against it. Making no difference. Now the freezer spray. Freezing it doesn't do a lot. Good. So I think I found a nice stable solution. I just need to build it or design it. So the new circuit's got to fit in the motor exactly how this did. So I'm going to measure this board up and make an accurate copy of it. I also need to have the adjustment pot in the same place so it lines up with the hole. I also need to be aware I need to have a bit of space around where the motor goes and the middle, because there's parts of the motor that interfere with it. I think I'm also going to steal this choke off here because it recommended a choking line, so I might as well use that one. And I might use the same pot because there's nothing wrong with it. So I've drawn up the motor control board in KiCad this time, which is growing on me. It's quite a nice tool. And in the 3D view you can see there isn't actually any components modelled because I didn't have time to do it, but it's not really worth it. If I flip this over we'll see the actual business ends, the actual copper. And that's how it's going to look, just how it works. And there's a hole for the potentiometer, which is important not to forget. DIY board making, you need to print these out on an acetate sheet. I also have several copies so I can double these up to get a better contrast, which gives you a better etch. I'm going to chop this out just around here. I'm going to make one smaller than the other so you can see it on top of the other one nicely. Just trim it up a little bit. Let's stick the second layer on top, slide it around so it's nicely lined up. Break out the homebrewed light box. Oh, I've got a habit of leaving the last thing I made in it. I've got a piece of single-sided pre-sensitised board here, so I'm just going to peel the plastic cover off. Keep it facing downwards and place it on there with our design on the top. Shut the lid, plonk the light box on top. 3.5 minutes that needs. There we go. Lights off. Out it comes. And then into the developer. We start to see the design coming through. When that's done, let's give it a quick rinse. Let's wash it all off. There we go. Now to add the etchant, in this case it's ferric chloride. Not particularly pleasant stuff, but keep it off your skin and out your eyes, you'll be alright. Pull a bit of tape off. I'm just going to make a little handle for the back of this. So I'm just going to float it on top of the etchant. Just like that. Balance it on there. There we go. Leave that to float for a while. So whilst the chemicals are doing their thing, I can harvest the parts on off this board, which is this pot for a start off. I've noticed the legs are bent over, so that's a bit of a horrible trick. So if I can get the soldering iron to bend them up. Seems like it might be bent sideways. Well, it's damaged the board, but yeah, I don't care. And now this one. Hope it's not so bent over. Oh, they're rotters, they have as well. Might be able to wiggle it loose if I'm lucky. Come on. There we go. Right on the floor. I reckon that looks done. Just let the drips drain off. And give that a dunk. Perfect. Next stage is to drill the holes. that's all cleaned up and labelled up now. Start loading the components. I hope it fits. Prise this cap off again. I mark this one with the plus now, because we know it's the right way. I'll try and wipe off this bogus one I did though. Know if it'll come off with IPA though. Oh, it has. There we go. No. A bit of wiggling's going to be involved here, I think. There we go. Put the cover on. I think that's it. Let's see if I've got it right. Well, it's rotating and it's not making a buzzing noise, so I think I have got it right. See how it plays. Just a bit slow that, speed it up a bit. Oh, wrong way. Motor's done again. What else is wrong? If I recall, I could never see this working, so I'm going to have a look into that. Allegedly, it can tell what type of Dolby's on the tape automatically. I'd like to rule out the tape's being dodgy and ideally use a brand new one, but I don't have one. But the nearest thing is one I've never listened to. Ooh. Let's open that. Get the obnoxious tape out there. Oh, they play a little bit of it. Maybe 30 seconds I played before I took it out. There's your automatic light still on. Let's see if it can detect it. Well, just a blinking light. It's not having it, is it? Yeah. I've actually bothered to print the service manual for this now because I need it. And looking through here, hopefully explains how this thing works. Well, lots of diagrams. Plenty of diagrams. Ooh. Now get to page 16 and here's the block diagram of how it works. All sorts of things going on there. And it mentions the auto Dolby up there. There's a few power supplies I should check. I reckon they're all working, but they're worth a look. And here we are, a description of how it works. The Auto Dolby Noise Reduction Selector System selects the noise reduction position automatically when playing back tapes recorded on this unit. Okay. An ultra-low frequency signal, table 1, is recorded simultaneously when the source signal is recorded on the tape by selecting the Dolby noise reduction auto and then selecting Dolby noise reduction B-type or C-type when recording with this unit. The presence, absence and type of ultra-low frequency signal are detected during play to determine the noise. So that can come out then. Not going to tell me anything. So I do have blank tapes that are pretty good, never used. So let's put that in there. Now to be a bit kinder to your ears, I'm going to record a 600Hz and 400Hz tone. A bit more gentle. And that sounds like this. So if I put it in Dolby B, press record, then play. And there you can see the left and right waveforms. There appears to be a little bit of modulation you can see, which I would agree with, very low frequencies, about 7Hz and 9Hz. It's supposed to be 7Hz on the left channel, which is the blue line, 9Hz on the right, which is the green. Of course, the advantage of the 3-head machine, you can listen to the source and the tape. And ideally, couldn't tell the difference between which is on. Doesn't sound bad. Press play. On the lead with the tape now. Doesn't know what's happening. There we go. Oh, nearly. Thinks it's B-type. It's not quite sure. I wonder about C-type. Will it perform better with that? Oh, what's going on there? That's not good. Right channel's gone mad. And a right weird sound too. Look at that. It's peg the meter making a squealing noise. It's not on a source, is it? No. Oh, crikey. Well, we haven't seen that with any of the playback before, so I think this is a recording circuit problem. Or maybe the Dolby oscillators? I mean, they were going crazy, weren't they? Now, the 7 and 9Hz oscillators can be picked up on this chip here, this analog switch, which lives on the auto Dolby board, this big one here. You can just see it behind this capacitor and these wires. There it is. Easy to probe from the back. Over. It's pin 1. We've got oscillation of some sort, we need to change the time base. Slow it down a bit. There we go, 100 milliseconds. Trigger menu, channel 1. Then I want to measure the frequency. Struggling with the signal, low amplitude, so zoom in a bit. Yeah, it's about 7Hz there. Then the other one's on pin 4. Yeah, about 9Hz. Yeah, that's working. Pin 8. 6.8, yeah. And then 9, 10, 11. 9Hz on there. Okay. So the oscillators work, I've got to look elsewhere. I hit record, see if the fault's still there. And it appears to be worse than ever. Look at that. I'll turn the Dolby off. Makes no difference. Oh, slightly. That's Dolby C, Dolby B, and off. It's not fixing it. Well, scanning through the schematics, and there's a lot of them on here, I've had a look at the record circuit. The record head's driven by this circuit here, and mainly by this op-amp here, IC502, which is an NJM 4560. There's no component IDs on the circuit board at all, so you have to use this guide in the service manual, and it's not the best. But the record and erase head goes into this plug here, so it's got to be around this area, I reckon. And here we are right at the edge, IC503, 504, is that 502? Yes, right by these pots. I'm expecting a bit of a noisy signal, so I'm going to change the waveform to a ramp on the one channel so I can tell them apart. Actually zoom in a bit on there just so I can see them more easily, and I shall also turn off channels 2 and 3. Leave me channel 1 right in the middle. See what we've got. So I have to lift the front panel out of the way to see it. And there it is. I have to run this machine on its side to get at it. There we are recording. There's pin 8. Well, that looks okay to me. And pin 2 is the output. Yeah. Not the mess we're hearing, is it? The output to the record head looks alright to me. Certainly didn't correlate to that racket we're hearing. So it must be the playback. The playback head goes straight to this preamp circuit here. This is an IC201, which is an NJM2043SA. See if we can find that. And the playback head's connected to this plug here, next to this relay. And there's this chip right next to it, and it appears to be attached okay. I'm not sure if it is IC201 though. Can't read it. So that's potentially it down there. Can't quite see the numbers, so get a torch on it. That's an NJM2043SA. If it is that chip, I can test the theory, recording again. I'm going to hit it with some freezer spray. I think that's probably it. Now I'll see if I can get the faults returned with a bit of heat. Just touch the side of the case with the iron. Oh yes. Well, that's enough to convince me that that chip needs changing. If I can find one. I don't actually have one of these. I've had one on back order for a week and then they've cancelled it. So, yeah, I don't know. But I do have an NJM4560, which is also used in this machine, and it has the same pin out. So, maybe this is a lower noise version, I don't know, but we'll try it. Just slide that into place. Well, now it's in, let's hope it's as compatible as I think. Well, there's no smoke yet, so good sign. I suppose let's record something. Well, we've got two channels. One's a bit bigger than the other. Compare that to the source. Yeah, it might need calibrating. Don't know why it should though, but hey ho. Playback gain is adjusted here. Just compare it to the source again. It's got to come down quite a bit. A bit more. Can't tell them apart to the other channel. Perfect. Before we threw our hissy fit on that one channel, I was looking at the Dolby detection. See if that's working or not. So we're going to select type B and record from the beginning. Then we go into type C. Then we press play, see if the Dolby detection can know what's going on. Well, it's picked up type B okay. A little bit of flashing going on occasionally, but it's mainly happy with it. And here's type C, eventually. Just checking out the calibration section of the service manual, shows you where to adjust the Dolby stuff. And explains here how you can adjust the auto Dolby board to give you the 7 and 9 Hz, as well as the level it should be at. And they're suggesting I use some antiquated test equipment here, which I don't have. I'm assuming dB refers to decibels relative to 1 volt RMS. And there's two test pins to pick up on, test point 11 and 12, which is on chip IC1D. It's another single inline package just behind this capacitor. Pin 1 is one I need to check, which I can also get on this capacitor leg here, it's a lot easier to get to. I'll set the line input to no volts. This is set to 100 milliseconds division horizontally and 100 millivolts vertically. So I'm looking for about 360 millivolts peak to peak. I'm a bit concerned about this noise though. Nothing on there yet. Well, the waveform looks about the right sort of magnitude, but what is it right on that noise for? That's crazy. Not sure about this noise, it's not good. It's not mains noise because that would be either 50 or maybe 100 hertz over here. It's a lot slower than that, and it's all over the place. IC1D is part of a low pass filter network whose job is to block the audible signals and just let 7 and 9 hertz signals through. There's plenty of parts around here that could be causing weird glitches, and as long as nothing's coming in from this end, it must be coming from here. So I can probably watch this bipolar cap there, see if I get any noise. And there's none. It's totally flat. Okay, onto this pin down here. The same. So we've got no noise coming in through this end. There's not a lot going on here, but I am suspicious of this capacitor here. Maybe if I disconnect that resistor, I can disconnect the two parts and see what's going on. Where we want to look, there's tape in the way, so see if I can peel this off. At least partially. Expose the bottom of it. There's pin 1 of the chip, there's the 5.6k resistor goes through there, and then we've got the capacitor I'm suspicious of. Although looking at it, it's not soldered properly. Got a dry joint. Well, that's easily fixed. Typically this board's soldered in and it's in the way, but this is on a plug weirdly, but I need to undo these cables. They're a bit tight. I don't know if I've got enough wiggle room. There's a bit. At least I can get to it now. Be a good idea to go over the whole board, because where you've got one dry joint, there's often more. Well, it's nice and flat now. Will it stay flat? Oh. Oh. Something just failed there. Something getting warm and failing. I wonder what it is. I just spent the last hour experimenting with that board, removing resistors, swapping capacitors and taking transistors out. Basically nothing worked. The only thing I can tell you is if I disconnect the input cable, it's nice and quiet. So it might just be an artifact of it being a low pass filter. But I am going to swap the chip with another one on the board, just in case. And this chip on the main board's for the microphone input. Let's try that. We have no waveform at all. In fact, if I zoom out, it's a bit slow to respond. It's a slow update on the scope. It's actually way off. It's down to one of the negative rails, minus 7 volts or so. And I don't know why it's sat there. There's no rhyme or reason for it. I suspect there's something wrong with the feedback network in that filter, but oh, there we go, it's just recovered. And you can see it's all wobbly. If I zoom back in, 100 millivolts. Yeah, and you can see trying to superimpose a 7 hertz signal on there, it's going to be very confusing. So it wasn't the amp chip, so that might as well go back in. Changed these capacitors here and this one here. I've even swapped the chip and even disconnected that resistor. When I did that, I still had the sort of wiggly line coming out of this chip, so it's definitely this way and it's not this part of the circuit. It's not clear what's causing this low frequency noise. I'm going to order some parts to rule them out, but in the meantime I'm going to have to repair something else. So there will be a part 3, but maybe a bit later. Catch you next time. Welcome to part 3 of the AWA tape deck repair. Hopefully this ends as a trilogy and doesn't end like Game of Thrones. The motor's been totally rebuilt, mechanism fixed, and now we're chasing some errant noise which has ballsed up the Dolby auto detection. Well, the Royal Mail have finally come good and delivered the spare parts I was waiting for. And another good bit of news, my vintage scope fixed itself. How's that happen? Just probably the sort of noise on this auto Dolby board. The playback signal passes through a pair of low-pass filters before going into these tone decoders. And we've got a lot of noise coming out of this 2.7Hz low-pass filter, which isn't there if you disconnect the signal. So, it's here. And that takes us straight back to this playback amplifier. I didn't have the right op-amp chip before, but I have now, the NJM2043S. Which I'm hoping cures this noise issue. We'll see. Let's turn it on. Oh, not hearing much noise. Well, the motor's not going round. Oh, don't you start that again. This motor's caused too much trouble already. Is there any voltage on it? Oh, no. Oh. That's a 12-volt supply that's gone down again. What's happened? This appears to be a bit of a recurring failure. We had to replace this fusible resistor before. Surely not again. These two series Zener diodes are shown there. They regulate the 12-volt supply. It's difficult to probe around here, it's a bit tight, but here's that fusible resistor. It's got the voltage on there, and these Zener diodes. Oh, it's working. Measure the voltage on here. Yeah, 12 volts. I think we got dicky diodes. Let's cool them down a bit. Oh, it just stopped. Did you see that? There we go, it just started up again. Well, the back covers have to come off again. Can't quite get at them. Oh, I really don't like how flimsy this is now. That board's holding everything up. That's them there. I don't know if it's one of them or both of them, but yeah, I'm going to change them. Clean those holes out. So what have we got? 4 volts and what's this? 8.2 volts. Well, 4.3 volts is the nearest one I've got. So I'm just going to lightly twist these together, if I can. Not too much. Put those in. Here we are, factory correct bodge. Let's get this the right way up. It's a bit wibbly wobbly. Line the tang up with a little hole. Just pull this chassis into shape. Back on. It's still not running. Maybe they weren't dicky diodes after all. There's definitely something round here. That resistor, that's for the base. Oh, look. Time I press it. Got to take the back off again. That's defending resistor there. 330 ohms. The measure's okay. I think I have a broken track somewhere. I can't see it being this resistor, not really. It could be flexing the board when I press on it. Maybe this transistor. Is that a tiny bit of movement I'm seeing? When I whip this out, I wonder if we've got a broken track. Well, that's not showing any broken pads, which is what normally happens when the track's broke. But do I see a little fractured solder ring there? It is. Well, you can barely see it. Just re-solder that then. Better put the transistor back in then. Let's try that then. That sounded better. Give that resistor a little rattle. No problems now. Perfect. So where were we? Oh yes, I just changed that chip. See if that noise has gone. We just probe pin 1 off that cap. Yeah, well there is noise still. Not as bad as it was. Let's test the auto Dolby out. Type B. Record. Play. Oh dear. That's worse than before. That's a familiar racket. I'm going to try some freezer spray on there. Gone quiet a bit, that screen's not looking good. It looks like the new NJM 2043SA is doing exactly the same as the original one. I'm going to try a different chip altogether. For a bit of a sense check, I'm going to put in something more conventional. I quite like the TL072. It's a nice op amp, low noise as well, but it doesn't look like that. So I'm going to have to make a little adapter board. Just going to use a piece of Vera board. It's already got copper strips on there, and I've already drilled out 4 spaces there so I can put the chip across there without shorting the legs out. Just poke the legs through these holes, like that. Then I can use this header, right angle pins, and can solder it to the board in the style of the original thing. I like to use a bit of blue tack, or whatever this is, a rival of blue tack, to hold the components in place. I'm going to put some wire links in. There we go. I need to skip pin 1, so it's not actually connected to anything. There we go. Let's see how it likes that one. Well, that's not an improvement. Oh wow. Yeah, I think that's even noisier. Let's have a look at all the dual op amps, see what the best one is I've got. And I reckon it's this. And this is the data sheet for it. It describes it as an ultra low offset voltage dual op amp. Very high DC precision. This sounds really good. It's got to be worth a try. Let's take this noisy op amp out of here. It's not helping. And out it comes. And in goes the poshest dual op amp I've got. the AD708. I've got high hopes for this one. See how it works. It's about as good as we've seen today. I'm going to leave it in. Okay, the Dolby test. Set type B, record, play. That looks more promising. I recognise those sine waves. And the output looks pretty good compared to the source. Yeah, needs a little bit of calibrating again, but yeah, pretty good. Let's try type C. I think we're in the shout with it's working. The moment of truth, can it detect its own Dolby signals? It's found it, type B. We haven't got any flickering. This is looking good. The sine waves are looking good on the scope as well. I think we've cracked it. Coming up for C-type now. Yes, perfect. I'm calling this one fixed. So that's sorted now. So the last thing to look at is the CompuBrain system. I think they eventually dropped the CompuBrain name and called it data. But whatever they've called it, it calibrates itself to the tapes. Let's try it. Oh, well, it looks like it's calibrated the bias and nothing else. It's given up. Now back to the service manual, because there is calibration for CompuBrain. There's not a lot about this. It's all written in this little box here. That's it. It's telling me the test points are TP8, which is on this little board here. You adjust it using a potentiometer, SFR1, okay. You have to replace the wire from the A to the B and connect the resistors that are on pins 12, 13 and 14 of IC11. So this is the main board, and the points of interest are SFR1, where the resistors go, laid out like that. The test points are there. This is our waveform, like a square wave. Where's wire A? Oh, here they are, A and B. Behind that board somewhere. Let's take our probe off here, finish with that now. Just hook our probe onto the test point. I've soldered this pair of 4K7 resistors to these connectors, so I can just fit them on here. This must be position A. It doesn't say the letter A on there, but it's in the right place. Point B is down here somewhere. I can't see it. There it is, got a torch on there. Yeah, just in front of that cap. We're on. It's reading 0 volts at the moment, so we'll adjust this pot, SFR1. Oh, it's gone high. Oh, low, high, low, oh. God, this is sensitive. Crikey. Oh, it's like nearly there. Oh. Now I'll see why it's not calibrating. I'm going to steal an idea off this power supply. It's got a coarse and fine adjustment pot, so you dial it in somewhere close if I want 10 volts. It's difficult to get it exactly on with this coarse knob, but then you use the fine adjustment, you can get it pretty much bob on. So this trimmer is a single turn trimmer. It's 100 kilo ohms, quite high. So if I insert another pot that's say 10 kilo ohms, it'd be 10 times more sensitive. Just got to work out where to put it. The schematics are quite small in this service manual. You can see the potentiometer here comes out of pin 10 of this chip, then through a little capacitor, C19, and it goes out elsewhere. And that includes wherever this goes, which is, oh, right over here. Oh, blimey. I decided to draw out the circuit like this instead on the whiteboard, but easier to follow. So what's going on? There's a chip here, IC13, whose job it is to create a 1 kHz test signal, 2 volts peak to peak. And when we put those test resistors in, it switches this here, passing this signal straight through this potentiometer, through this capacitor, then it goes off to different parts of the circuit. It's interesting to note that point B that we connected to is one of the outputs from the Dolby record board. So we can put our trimmer anywhere between here, or here, there or there. which is anywhere around the vicinity of here. This is IC11, and these are the test resistors, or the test points, pins 12 to 14. If we look for pin 10, we go 14, 13, 12, 11, 10. Follow that trace. It goes to the potentiometer, just like it's supposed to. This leg and this leg are shorted together. Okay, so we can either break a track here, we can follow it from here. This goes to this capacitor here, which is C19 down here. So where does it go? Follow this track around the bottom here. It goes up there. This part here. Well, I think that's a wire link there. That's handy. We could take that out and sneak our pot in there. Grab back the tweezers in case it's a bit hot. Or stuck. There we go. I've actually found a 10 turn pot here, 10 kilo ohms. That's going to be perfect. That'd be very sensitive. What I need to do though, just need to bend the legs. The two of them are shorted together. Pop a bit of solder on there, make sure they're well connected. And just pop it in here. Power it back on. Let's get some course adjustments in. Of course, it's not very far off. Okay, just get it closing in. Look at those square waves. Trying to get them as even as possible. Oh, back a bit. There we go. Beautiful. Not as stable as I'd like, but at least it's oscillating. That's something. Pull our resistors off. Let's take our CompuBrain measure lead off and put it back on position A. Let's try it now. Still the same. From what I've read about these tape decks, they're very difficult to get right. There's a few things you need to check. And there's a lot of noise about power supply noise, and that comes from the capacitor police. But I like to check the power supply rails first. This tape deck's got a dual rail 7.5 volt supply for all the analogue stuff. That's the important part. I'm going to probe pin 8. That's where the positive rail is. 7.648 volts. 320 millivolts peak to peak ripple. I'm not sure that's even true. Let's take the probe off. It still says that when I'm not touching anything. Try the negative rail on pin 4. Yeah, 7.653 volts. I can't see any ripple despite what this thing says. Let's zoom in on that ripple, AC coupling, and just wind this right in to say 20 millivolts. So pin 8. That's about 10 millivolts of ripple there. Just a bit of noise, nothing really. Negative rail. Yeah, the same. Yeah, I don't know about those spikes, don't know if I believe them. I get the same ones when I touch the chassis. So I don't think it's a power supply problem, but there's a lot of adjustments to make. So for an experiment, I'm going to put all the potentiometers back to their mid positions. And then I'm going to measure the output of different types of tape. This one's a normal bias. It's got about 2.8 divisions on the bottom, and what's this? About 1.9 divisions for this one. Now I've got a type 2, or a chrome tape. It's a lot less actually. This one, about 2.2 divisions. And this one up here, what's this? That's loads less. 0.8 divisions. Now I've got a metal position tape. Quite expensive these are. Very similar on this channel, about 2.4 divisions. This one's not even, oh, that's about a third of a division. Each one of those tapes had a progressive capacitor EQ, so they've got a high frequency response. There's something wrong with the right hand channel, definitely. And just to prove it's just a recording problem, here's a commercially recorded tape. And there's nothing wrong with playback, very healthy. And this is the calibration procedure for all this, and it refers to lots and lots of different test tapes you need. I've actually listed them out. It turns out there's only 5 different ones. Unfortunately, 3 of them are blank. The first step of electronic calibration, part 3 here, is to adjust the frequency adjustment. That requires a test tape with a 10 kHz and 1 kHz signal on there. It's pre-recorded and I haven't got one. I'll have to skip this step. Step 4 is a playback sensitivity adjustment, again requiring a pre-recorded tape that I don't have. And all these trimmers are set to the middle, and to be fair, it played back okay, so it can't be far off. I'm also going to skip the meter adjustment because I actually don't think there's much wrong with them, and I doubt they've got anything to do with the problem we're experiencing. So the first thing I can look at is a bias oscillator. Check it's running at 85 kHz. We can pick that up on this wire here. Press record. It'll help if I put a tape in. Well, I can't see the measurement. Let's zoom in on this. It's quite a high frequency, 85 kHz. We've got 84.9. I'd say that's close enough. How do I shut that up? No, it's better. Now on to step 7, bias oscillator output adjustment. And I need to put a type 2 tape in there, a chrome one. Then adjust the measured voltage down between minus 3.8 to minus 4 volts. Okay. Put the chrome test tape in. Take our test lead off this test point. And onto this one. Zoom in a bit. 1 volt per division. So I can get this line adjusted to the bottom of the screen. This is L505. Oh, that's the wrong way. It's coming back up. Oh. It's already set at minimum. Nowhere near where it's supposed to be. Onto this test position. Oh, it's off the screen. Where is it? Oh, there it is. And onto L506. Can I adjust it? Oh. No. That's having no effect at all. Okay. So I think we're closing in on this. To try and understand it, I want to see where this test point is in the diagram, see what we're measuring and what we're adjusting. We're actually adjusting this here, L505 and L506. I don't see a test point 5. We'll trace out a left-hand channel first, because that's what's shown in the diagram in detail. So this is our test pin, goes through a wire link, and follow this track, it snakes around here, comes up there, onto pin 8 of IC502, the record head amplifier. And there's pin 8 and it says test point 7, so that's wrong, it's test point 5. So the complementary output on here is pin 2, which is here, so if we trace this signal back, goes across the link there, snakes down here, yes, into our test pin. That's the one. Just looking to understand what we're actually doing when we adjust this. By turning this, we're adjusting the coupling between the two sides of this transformer. Literally, it's feeding a signal in from here, which is a centre tapping of the main bias transformer. I'm going to check the obvious things, like that there's continuity here. Yeah, 9 ohms, about this one, another channel, 9 ohms as well. Okay. And this one, 1 ohm. 1 ohm there as well. So what we're seeing is this op-amp trying very hard to drive this transistor. It's trying to get this to pull as much current as possible. There's something stopping it. I do see a fusible resistor, 47 ohms. And there they are, right next to these transformers. They look alright. Let's measure them. So this is the good channel. Oh, 235 ohms. What's this one like? 475. That's out by a factor of 10. These aren't the first fusible resistors we've seen drift high in this machine. So let's get them out. Let's fish these out. Back in the specialist resistors again. We looking for 47 ohms. There we go. Pull a couple off here. Wiggle them in, they're a bit awkward. Look at that, beautiful. So will it calibrate now? Let's see. Power on. Put it into record. Well, that's instantly better. Look at that. See if we can adjust it a bit more. Oh, the wrong way. We're going to go for 3.9 volts, the midpoint of where the service manual said. Look at that, perfect. Let's stick it back on that other channel. So that wasn't right either. Well, that one's actually a little bit too far negative. I'll bring it back. Excellent. I won't waste your time changing caps on this machine. Just change all the resistors. How bonkers is that? So next up is bias strap adjustment. Got to put a metal tape in for this and pick up test points 6 and 7. Well, here's test point 6. I need to zoom in a bit here at 2 volts per division. I might wind the time base out as well so we can see what's going on the tape. Just make the adjustment, wind it in. Oh yes, just there. Let's pick up the other test point and make the same adjustment. Oh, it wasn't far off. Let's shut that up a minute. The next stage is to adjust the frequency characteristics. We've got to supply 1 kHz source, adjust it to 38 millivolts on the line output, and then basically compare 1 kHz and 10 kHz signals and make sure that they're slightly different. I've got the line output connected to this old scope and it doesn't measure anything. And I'm also going to take these out from the amplifier because that's got a 47 kilo ohm resistance, which is dragging it down a little bit. Just going to pop this on here. So I can connect it to these multimeters. So what does 0.5 to 1 decibels of gain mean? Here's a definition of how a decibel is calculated from a ratio of voltages. But in our case, we need to know what the linear gain is. So we've got 38 millivolts times 10 to the power of 0.5 over 20. I can't work that out in my head, so that's 38 millivolts times 10 to the power of 0.5 divided by 20, which is 40.25 millivolts. And the upper limit, same calculation again, (1 dB). 38 times 1 over 20. 42.64 millivolts. I've managed to coax line output to be 38 millivolts on each channel. You can appreciate that's difficult to measure accurately on an analogue scope, and this also needs standard type 1 tape in there. Now to change the frequency to 10 kHz from both channels. It's caused a slight increase in amplitude, but not enough. Although it helps if you press play. Oh dear, that's quite low. Well, that's not the 40 millivolts we're looking for. Let's see if I can adjust it. Start with this channel. Oh, that's making it worse. Go the other way. Oh. It seems to have a centre sweet spot. I wasn't expecting that. That's pretty much where it started. About this one. Yeah, same effect. Although this is not so responsive. It's about as good as it gets there. Just trying to figure out what's going wrong here. What this pot's actually doing is it's manually allowing us to do the automatic adjustment to the bias. But everything seems to be working very sweetly at 1 kHz. And I don't see exactly how this will affect the frequency response. Different frequency responses are required are done in the feedback circuit for the record amp. Each little individual filter network is called in by these transistors, depending on which tape's been selected. It's interesting to know that that frequency response is adjustable for metal tapes. The different bias levels are switched by these transistors here, and they're not actually adjustable, they're just fixed with fixed resistors. I should check the output of the record amp just to make sure that we're not losing a signal there. Our signal comes out on IC401, pin 7, through here, through this capacitor. That'd be a good place to check actually. Could have a problem there, maybe. Start with the left channel, IC401, signal comes in on pin 3, there it is. Comes back out, pin 1, much bigger. And there's a 22 microfarad cap here. There's the signal on that side. And it's still there the other side. Nothing wrong there. A lot harder to get at, this one's with boards in the way, but pin 3 there. Signal's there. Pin 1's the output. There we go. Looks pretty much the same. We've got a 22 mic cap tucked in there. Signal, both sides the same. Perfect. I forgot to mention that's at 1 kHz, so I'll do this one at 10 kHz. Let's check the left hand amplifier, input pin 3. There it is. Okay. Pin 1. Whoa. Loads of amplification. Yeah. There's definitely some EQ going on. Then gets that capacitor again. Yeah, that's good. This side. Yeah, no problems. And the right hand amp. Pin 3. Okay. Output. There it is. Then the capacitor. That leg. Yeah. And the other leg. All good. Looks like the recording amp's working, and that sounds like a good thing, but it's actually bad news. It means I don't actually know why this isn't working. There could be lots of things. It could be a bad tape, it could be the heads. I'm not sure. In a last ditch effort, we never managed to calibrate the playback EQ because I haven't got the factory tape, but let's see if I can adjust it right here. Let's look at the source again. We need our waveforms that big. It's not really helping much at all. Sweet spots about there. What about this one? No, making it worse. Yeah, it's about as good as it gets. I'm not actually sure I'm going to be able to fix this problem, but there is different settings for the metal tapes. We've basically got to do the same thing again, but using different pots. So we stop that then. Put the metal tape in. There's our 1 kHz signal, pretty low level, so yeah, a little bit jittery, but you see the amplitude. You've got 28 millivolts there, 31 millivolts there. We can balance those up later. Just change this to 10 kHz now. And the level has dropped, but not as bad as before. Look at the source again. So we're looking for about 2 divisions vertically in each one. There we go. At this channel. As good as I can get it. Put this back to 1 kHz. Just check the source. Just got just over 2 divisions on each one. Just in the right channel first, it's easy to get at. And now the left channel. Okay. So for the metal tapes, we've got the low frequency and high frequency response pretty similar, so we're in with a chance. But the CompuBrain does actually do a 13 kHz test right at the end. So here we go, 13 kHz, both channels. It does look very noisy compared to the source, but yeah, I don't know. Maybe. There's only one way to test this. We'll hook a probe onto this resistor here so we can see what goes on when you do a CompuBrain calibration. We'll keep our fingers crossed. It starts off with 400 Hz to detect the tape. Now it's switching between 1 kHz and 10 kHz. And now it's adjusting the level by changing the gain. It failed that time. Restart. Comparing 1 kHz and 10 kHz waveforms. Now it's adjusting the gain. If it passes that, the EQ is tested with 13 kHz. There we go. And it's failed. But it didn't fully calibrate the tape because it fell over on the 13 kHz part, the final part. So I agreed that it shouldn't calibrate. So that's telling me that the CompuBrain calibration system is actually working. If we just take this metal tape out, which is good quality, high bias tape, and put our bog standard type 1 in, will it calibrate that? I doubt it. Yep, and now we know why. As I mentioned before, I don't know how I can improve that frequency response, and it could be the tapes. They are old, like 25 years old. I don't know what their lifespan is, but we're pushing it. Well, I think I'll take the tape out and we'll start the rebuild. Get the scope probe back out as well. Don't pack that in there. Get the test leads off as well. Stop them tangling up. It's been a while since I took this apart, so I'm just trying to remember how it all went together. I know these pots definitely poked for this chassis. Make sure they're on tight, so you can't get these nuts with the cover on. Try and get this metal chassis to line back up with the screw holes. That's about right. Let's get a screw in there. The same on this side. There's a lot of wires in this, and it's pushing back. Spring loaded. Let's push the headphone jack through the hole. There we go. Get the nut back on it. Preferably straight. Don't want to cross thread your headphone jack nut. Just give it a little tweak with a spanner. That'll do. Next is a timer select switch. Cable's only just about reach. Tiny screws in there. Not forgetting the little felt disc. Keep it looking smart. I'm going to feed the main switch through there. That's the right position. Then your jack button cap. That fits on there like that. Then the power switch cap. Just there. Getting this front facer on's a bit awkward. It's best to lift this up. Just wedge it on something. Then we can lift it into position. Then just give this a bit of a wiggle. And it should just find itself home. There we go. Let's get the screws in before it pops back out. Let's fasten the top of the tape mechanism in. With every screw going in, this is getting a lot less floppy. Now we can put the bottom cover on, which gives it the benefit of 2 more feet. You just get these little plastic fixings back in and use the wire cutters just to squeeze them up so they can push in. Then just push these locking pins in. Put these knobs back on. I think this one's in the centre anyway. Yep. I don't know about the output level, so I'm just going to engage it there, turn it all the way down to minimum, take the knob off, and put it back in the minimum position. Little bit of a fiddle. Just clips on if you can get it right. There we go. Just a bit of housekeeping with the wiring. I seem to think it was sort of tied up. Trying to include all the wires I can. on with the cover. Last time we're seeing in there. And not a single screw left over, not even after all these months. Well, it's in better shape than when it first arrived. This tape deck's been a real ordeal right from the beginning. It started off with a seized motor, which I had to rewind. And then we had the blown 12-volt power supply. Then we had loads and loads of fusible resistors failing this thing. Then we had the issue with the mechanism. The take-up reels weren't working. That turned out to be a motor was installed backwards and needed some rubber parts replacing as well. We had the Dolby Auto Detect not work because not of one, but two faulty amplifier chips. Now left with the issue for recordings where high frequencies aren't high enough for the auto calibration to work. I actually tried changing some components in the EQ circuit to see if I could correct for it, but I don't really know what I'm compensating for. Worn heads, dodgy tapes, I don't know. But this thing, it plays, it records, and it's going home. Catch you next time.